This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
All right, we're on. Today, we're going to talk about software as a medical device. Now, I know for a fact that we weren't supposed to have this lecture until next week, but I thought because quite a few of you guys have a software component to the devices you're developing in your workshops, I thought I'd move this forward a little bit to make it clearer. Right. But first, we're going to get back to our quiz, which we haven't done in a couple of lectures, and it's going to have a little twist today, seeing that we already did a lecture on the classification of medical devices. If you can get the class of the device without cheating, you get a photo file. I did bring some. So, is it a medical device, and if it is, what class would it be? I'll let you have a think about it. So we've got crutches. No. Then we have, okay, this is probably straightforward, sterile adhesive bandage. We know for a fact that that is a medical device, but can you guess what sort of class it's going to be? There is a special class for sterile devices. Then we have the good old-fashioned hypodermic needle. Lung ventilator, clinical thermometer, one of my favorites. I reckon that's a hard one. Pacemaker, I think you guys should all know what this one is, I hope. And then we have we haven't talked about spinal implants, but there's a stent that you can put in. Defibrillator and spinal cord stimulator. So obviously they're all medical devices. So crutches are in fact a medical device, but they're like the lowest class you can possibly get. They're right up there with the tongue depressor. In fact, the tongue depressor would be a higher risk because it touches a mucous membrane. So sterile adhesive bandage would be a class 1S, which is class 1 sterile device. So if it doesn't have a medicine on it, if it has a medicine on it, then it's going to be a class 3 medical device. Hypodermic needle is a class 2A. So it's higher risk, but it's still the basic one of the medium risk devices because it enters the circulation. Then we have a lung ventilator, which is a class 2B medical device. Clinical thermometer is a class 1M. M stands for measuring function. So with the class 1s, we have the basic class 1. Then we have class 1S, which is class 1 sterile, and then we have class 1M, which is class 1 with a measuring function. So if you're weighing in a cup and it has like the volumetric guide on it, and they're going to use that to measure the volume of urine that you output, then that's going to be a class 1M medical device. Pacemaker is an active implantable medical device, but it actually gets treated as a class 3 device. It just means that an extra standard applies because it has a power source. Spinal implantable stents, so anything that goes into the central nervous system is automatically going to be a class 3 medical device. Defibrillator is another active implantable medical device, and a spinal cord stimulator is another active implantable medical device. All right, so this would make a very good multiple choice question. So it's nice to be familiar with this. Okay, so I've redone this test with software tools. Now this can be harder because we haven't actually done this lecture yet, but I want you guys to think about it. In lecture 1, we talked about what makes software a medical device, and the gist of it was, does it have a therapeutic or a diagnostic function? So that would make it a medical device, right? So we could have a look at these. I don't know, I sort of want to get a show of hands because I think some of these are a little bit tricky, but I'm curious as to what you guys think. So would a records management system be a medical device? Who thinks no? Okay. Correct. You guys probably you all have this app on your phone, the movement tracker for healthy lifestyle, or there's like a multitude of healthy lifestyle apps on the app shop or whatever. I've got a bunch of them in my phone that I never look at. So is that a medical device, yes or no? Okay. Software which analyzes and interprets ECG signals. Yeah, that's definitely a medical device. Okay, this is a tricky one. A medical textbook app that provides a source of information or advice to health professionals or consumers. It's not actually. Yeah. So it provides information, but the doctor's supposed to interpret it themselves. So, yeah. Okay, what else do we... Yes?
Does having the fact that it provides advice change anything?
If it's a textbook, it doesn't. So it just depends. It's a bit iffy. Yeah.
What if it was an app that took textbook information and then had a diagnosis?
Then it would be. If it had a diagnostic function or it gave you the likelihood or a diagnosis after you've input your symptoms in it, then yes, it definitely would be a medical device. So therein lies the difference. All right, so mobile app used to measure blood glucose levels for monitoring diabetes. Yeah. A dosage calculator app where it can convert your value into how much of what you need to put in. That's a bit trickier. Software running an infusion pump to control dose delivery. That would be a medical device, but it's different from the dosage calculator app. Software controlling a pacemaker, obviously. And software that collects information and makes a clinical decision or referral. All right, so these were a little bit tricky, but I think it's, is that a bit more obvious? So yeah, the tracker apps for like health stuff, But anything that interprets diagnosis would probably be a medical device. All right, so we're back to the regulatory approval stuff. What makes software a medical device? How is it regulated? So we're going to cover all of this in the lecture. Which one is which? Which one is a medical device and which one isn't? There's a specific standard, for software as a medical device, which we're going to look at. And then there's the International Medical Device Regulators Forum. There's some other considerations, including post-market stuff and global reforms. Now, I have to mention that regulation of software is really, really new. So it's still all a bit vague, even though there's guidances in place that have just come out in recent years. The only time it gets challenged is when you actually put a submission through. Now, I know for a fact that if you go to the app shop on your phone, there's a whole heap of apps that would fit into this definition. And I think that once the definite guidance comes out, the TGA is going to crack down pretty hard on them. So there's a lot of change in the space at the moment, and it's really, really vague as to what the actual rules are. Oh, story time. So I thought this was really, really interesting. I was reading, I don't know when this was, but I was reading about this black market. Yes?
I was going to ask, the application already exists, and then the TGA changes the regulation. What happens?
Well then you can't, yes, you can't. You can no longer sell it, just like with any medical device. Let's say when they reclassified joint devices, they went from class 2B to class 3 overnight. So they allowed an 18-month grandfathering period where if you wanted to keep selling your joint in Australia, you had to submit a conformity assessment application for a class 3 device. So you had to have all this extra information on your joint, which generally meant that you needed extra clinical data, and you couldn't use the predicate device to say, well, that one was safe and this one's only a little bit different, so it should be safe too. Right? So they'll usually allow a really long grandfathering period, like 2 years, but after that period expires, you cannot no longer sell your joint unless you reclassify it. And they'll give you a discount to like put it back on the RTG in the correct category. But yeah, so you can be in a situation where overnight you have a warehouse full of medical devices that you can no longer sell, and that they can no longer use them in the hospitals either. So it's a very bad place to be. Yes. I just found the story interesting. I was reading about a black market for these old obsolete units of insulin pumps, and the reason that they were so wanted is because they're hackable. So they're no longer being sold, but they'd go for like thousands of dollars online. And the reason people were buying them was because they work better than the newest model of insulin pumps that Medtronic was selling. So who here, you don't have to show if you don't want to, but does anyone either has type 1 diabetes or is familiar with someone that has, like in your family, type 1 diabetes? Anyone? All right. I'm going to presume you guys know what it is, but it's basically when your pancreas doesn't produce insulin. So you have to have additional insulin introduced into your system, and it regulates your blood sugar levels, right? So because you no longer have that feedback loop, what happens is you have to guesstimate the amount of insulin that your body needs, and that's not a precise science. And if you're type 1 diabetic, it means you're not producing any insulin at all, whereas a type 2 diabetic means your insulin receptors are not as responsive, so it's not as terrifying as type 1. So what happens is you have to constantly keep measuring your blood sugar, and then you have to, if it's too low, you eat something sweet. If it's too high, you have to inject some insulin and keep it balanced. And it's really brutal. When you're little, your parents do it for you, but as you get older, you have to do it yourself. And the problem with this is because it's not a precise science, let's say you have a really long night's sleep. What happens when you're sleeping? Your metabolism is working, burning energy, so your blood sugar drops. If you don't wake up at a certain period of time, let's say usually for most people it's about 4 to 5 hours. If you don't wake up every 5 hours, check your blood sugar and dose as required, you run the risk of never waking up at all, because you can have a hypoglycemic episode where you lapse into a coma and you die. So a lot of these people with type 1 diabetes don't really ever get to have a full night's sleep. For example, you always have to think about, what am I doing today? So if you know you're going to be walking to your class and it's like a half an hour, 40-minute walk or whatever, you have to compensate for that. So you have to be aware of your physical level of activity for that day. You have to be aware, if you're like going out to lunch with friends, where there might be some food, you're on a very restricted diet, or you choose to have like some cake, then you have to compensate for that too. So it's pretty intensive. You had to measure it in manual syringes, and insulin has to be refrigerated and so on. So 6 is nothing. Most people do it about 10 times a day. Right, so they developed insulin pumps. So for ages, they had 2 separate devices. So one of them was an implant that would continuously monitor your blood sugar and tell you what it is. But then you had to adjust your pump, which was a separate device, and you had to manually input how much insulin. So you still had to work out the level of insulin required based on the current value, put it in, and then the pump would sort of slowly release that insulin levels. I forgot to mention that not having a good insulin control leads to organ damage and all kinds of issues like blindness and I think, what does my dad have at the moment? Diabetic ulcers, and he's going blind and all the rest of it. But so yeah, so they had this. So it was an open. They used to call it an open loop system, where the human was one of the critical ingredients. So someone said, I think it was a woman, one of the hackers they said there has to be a better way to do this. So what they did was so one of the old Medtronic pumps was totally hackable. It had like 0 security on it, because this was back in the day when cybersecurity wasn't as big an issue as it is today. So they closed this. So what they did was they wrote some code that would continuously monitor the output that your blood glucose monitor is putting out, and then they wrote an algorithm that would guess as to what your blood sugar level requirement is, with a 5-minute delay, and then it would continuously send a signal to your pump to dose it automatically. So you wouldn't have to, like, it was continuously doing it on a loop. You wouldn't have to get up and manually do it yourself. So you could actually have a good night's sleep and not worry about it. So yeah, and they published it free online, and they wrote a tutorial on how to actually hack into your pump and do this. So they designed an open source artificial pancreas system known as Open Apps. And all of a sudden, everybody wanted these pumps. That was an early version of what the loop system, so they called themselves loopers, looked like. And yeah, instead of micromanaging your blood sugar, people could offload that work onto an algorithm. So you needed to buy like a mini computer, like an Edison, that's not an Edison here, to receive data wirelessly from the glucose monitor, and then it ran an algorithm to predict future blood sugar and told the insulin pump what to do. And you could monitor it on your phone if you chose to do so. So obviously this is a high-risk thing, but I don't actually think there were any recorded patient deaths from people that were looping. So they did this about 4 years before the medical devices company did it. And the medical Medtronic really discouraged this because it was off use. But people who were doing it loved it, and as I said, now they've put out a model that actually does this for you. So there is a closed loop model that came out recently, but it's like hugely expensive. I think it's like $7,000 to buy, and it doesn't work as well as the looper devices. So at least that's the initial feedback. So yeah, and I don't even think it's available in Australia yet. I just thought this was an interesting application of software. All right, so for example, I'm going to use low-cost gaming technology as an example. So what you can do is you can get some custom algorithms or open software and apply it to the Kinect. So you can just add some code and it's going to analyze your movement and apply it against clinical criteria. So then a physio can use that to either diagnose you or to monitor, let's say, your recovery, or a clinician can use it as well. So you could look at neurogenic walks. There's different gaits associated with a different disease. And this technology actually got validated against a current system. So you could look at static, dynamic posture, range of motion, gait, so on. And they were thinking about having specific markers on the patient to improve the accuracy of this technology. So this actually exists. I knew the student who made it. So this does fit the definition of a medical device because it diagnoses, monitors, treatment, alleviation, or compensation for an injury or disability. So it's monitoring and disability, and you can also use it for diagnostic purposes. So how is software regulated by the TGA? It's regulated under the medical devices provisions. So it's pretty much the same as a medical device, and it goes through that entire process. And standalone software by itself would also be considered within this framework. So the main difference here is if it's an integral part of a medical device, it doesn't get assessed separately. So for example, the software that runs a pacemaker is deemed to be a part of that device, and it gets assessed as part of the pacemaker application, but it won't be assessed separately as a medical device. Again, it's risk-based, and everything depends on its intended purpose. The classification of medical software in Australia is a bit iffy. So it says basically, if it's used in a system, so if you like attaching something to your phone to monitor your blood pressure or whatever, if it's used in a system, it automatically becomes the class of your highest risk item within that system. If it's used as a part of a device, then it's not regulated separately, and if it's used by itself, then it is. And again, all medical devices are expected to meet the essential principles for safety and performance. But most of medical software, as it currently stands, would be deemed to be a class 1. All right, so basically what I said. So it'll fall in the same classification as that device. If it's an accessory to a medical device, it's classified separately. And this is interesting, the regulators make no distinction between different forms of software. So all software is the same as far as they're concerned, and if it meets the definition of a medical device, it must conform the same. So there's a specific section in the Australian regulatory guidelines for medical devices, and I've got some parts of that later. So intended purpose of the device, this is really important because you decide what this is. So under the Therapeutic Goods Act, it's whatever you tell the TGA it is. So if you say the indication for this particular device is so, they're going to assess it as such. But if you put something else on your label, then that's a bit of an issue. But yeah, they're going to assess pretty much everything that you give them. So if you say, oh no, my software is just provides information to help in the diagnosis of, but on the box you've put diagnose so-and-so condition, then that's obviously a problem. All right, so does it provide a diagnosis, prevention, monitoring, treatment, or alleviation of disease? Okay, so as we said, therapeutic or diagnostic function. So many mobile applications are simply sources of information, and the TGA doesn't care about it. Unless it's to do with advertising of therapeutic goods or labeling and instructions for use for a medical device. There are some products that have a role in diagnosing or managing illness that use software that would fall under the definition. So again, we have the diagnosing a condition or disease versus a measurement tool. So this is straight from the TGA website. So it again talks about, I've included stuff directly from the website because some of the stuff I interpret a little bit differently than some information that's been put out there by the TGA. So I've included both. So it is really iffy. It's quite vague, but they're in the process of actually putting out specific regulation for software as a medical device, which will make it a lot clearer as to what the requirements are. So yes, again, accessories connected to or embedded in the platform, software that is a part of a medical device, and apps that control a medical device are to be considered a medical device themselves. So which software is a medical device and which one isn't? So analyzers used for pathology, detection of disease, patient monitors, pacemakers, and infusion pumps are. Some smartphone apps that measure blood glucose levels, body temperature, X-ray image processing software, and diagnostic software are. And the computer and mobile phones and tablets aren't. So they're just used to display the software, but in themselves, they're not deemed to be a medical device. Okay. Things that are not medical devices, so software tools not considered to be a medical device, is general health and lifestyle apps, software that is a part of a current device, so not regulated separately, apps that control a medical device, so it's an accessory, and apps that rely on hardware in addition to a general purpose computing platform, so sensors to achieve their intended purpose. All right, so this is the actual guideline, and it talks about which type of software and how would it be regulated, and then it has examples. So I think that, yes?
When you said that software that requires hardware to achieve its purpose isn't regulated as a medical device, is the hardware itself regulated as a medical device?
Yes. So the hardware itself would be.
And that negates the need to regulate the software?
Yes. So it would become a system, if that makes sense. And then it's, if your attachment is going to be a class 2, your software is automatically going to be a class 2 and assessed as part of that device. Does that make sense? Because they'll look at the entire system, not just the small part that does the measuring. Right? I hope that makes sense. Okay, so here they've sort of listed the different types of software as far as the TGA understands them. However, this is quite outdated now, and we know that there's a lot more out there. So hopefully the next iteration of the specific regulation for software is going to tell us a lot more. Does this answer your question? So it actually specifies how it's regulated. So if it's an accessory to a device that is a device in its own right, and it's supplied separately, then it's a separate medical device, right? If you have to buy it separately and then put it together. If you're selling it as a kit or a system, then it's not. So I think that our example would be software that is used as a diagnostic or a therapeutic tool. The Connect example that we used, so it would be a separate medical device. And there's some examples there, but so even upgrades to software that are supplied separately can be deemed to be a medical device as well. All right, so if you got a device and it had some sort of software error in it and you sent a software package to fix that error, do you think that would be a medical device or not? The software package itself? No. Okay, and what do the guidelines currently say? So these guidelines are under revision. So for our device, it said that if the device is supplied as a complete unit, the classification of, again, we're just repeating the same thing, it would be a Class 2B device, and you have to apply this specific standard to your software. So that's like the golden standard that you apply for software, even though it's been around for a little while. And when it comes to IVD, there is a distinction. So software that is used to just like run the instrument or analyzer is not a medical device, but if it's used to interpret the data that the instrument collects, then it is. And the IVD classification system applies as well. All right, so how would you comply? How would you provide evidence that you comply with the essential principles if all you're producing is a software package? And the answer is exactly the same as you would for a medical device. So you need to have a QMS system, you need to have a version control in place, you need to have release management, which would be different from like if you're manufacturing a specific product, but it's the same sort of principle that we went through last time. So you need a risk analysis, you need design validation. The big one is bug issue reporting and correction. So that's pretty important for software. You still have to have clinical evidence that this app actually does what you say it does, that it works, that it will give you the correct results if you're using it for diagnostic purposes, and that the benefits of using it outweigh the risks, right? So I think one of the big issues that the medical device company, when it came to those like hack pumps, had was the fact that if it failed, it could be catastrophic failure. So if it stopped working or if there was a glitch in the system, they could like overdose you on insulin and you could die, or they could underdose you on insulin and you could go in a hyperglycemic episode. So yes, you do not generally want to be hacking your medical devices. And the trick is to document all of this. So there are a few very important standards when it comes to medical devices incorporating a software. So it's the standard ISO 13485. Then it's the risk assessment management standard, ISO 14971. And the new one is the medical device software lifecycle, lifecycle processes. So it's the IEC 62304. So let's have a quick look at that standard. It's been around for a while. So when the software exploded in 2006, this actually probably around the early 2000s, so this standard came out and it was adopted by pretty much everyone. Now Australia does not require that you use it. However, if you want to, a lot of other countries do. So if you want to sell your medical device overseas, you would need to be compliant with the standard. So it's like one of those optional things, but it's a really good way to illustrate that you meet the relevant essential principle. So what does this standard do? It provides a framework that supports the risk-based approach to software. So yeah, it applies ISO 14997 specifically for software, and it classifies it based on the level of hazard presented to the patient and or the user of the device. So if it's a Class A, it means no injury or damage to health is possible. So if it fails, it's not a big deal. Class B is non-serious injury is possible, and Class C, death or serious injury is possible. So based on which class your specific software would fall into, then you have to do all of this software process control for it, right? So the more you have to rely on software to treat the patient, to monitor the vital constraints, or to give a diagnosis, the higher the class is going to be. And it's, again, it's risk-based. It's based on the outcome to the patient or to the user. So for example, you might be required to do a lot, well, you have to do software maintenance for all of it, but for example, if you look at serious injury, you have to hit every single one of these processes. So you have to have a development plan, you have to have all your standards in order, you have to clearly illustrate your requirements, have to have your risk control system in place. Now, identifying the software architecture and talking about how it fits into the risk management system is great, but it can be a bit problematic with like black box systems such as deep machine learning, where very few people in the world actually understand how it works, like the nitty-gritty of how it works. We know that it's a black box. You put in certain specifications and the computer will teach itself how to interpret them, provided that you've given them enough data to come to its own conclusion, right? But how it actually works, I don't understand it, and I know a lot of people that work in that area don't specifically understand the science behind that. So it can be problematic, but as long as you can demonstrate a lot of this, such as implementation, unit testing, detailed unit testing, as long as you can demonstrate that it's safe, then you might still be able to get through the Class C serious injury definition of it. All right. So this standard links directly to EP2. So I know we looked at this yesterday. So minimize any risks, identify hazards and associated risks, eliminate or reduce these risks, and inform users of any residual risks. So it's the same sort of thing that we used for devices, applies to software. And you can actually go through this entire process with software as well as a medical device. So, all right, so I've put this, this is directly from one of the TGA presentations. And the reason I put this in there is because if you look at the language, you realize how like vague it is. So they use word like may include and likely includes. So for a regulator, that's a pretty big deal. Like that's, it just means that they don't actually, they're not 100% sure as to how to regulate these types of devices. So it's open to interpretation, and you get to make a case yourself as to what you think, as to where you think your medical device fits into. So it's a case-by-case basis, and just because you think it fits into a category does not mean it's actually going to get through that category. So yeah. All right. There is an International Medical Device Regulators Forum. So they're actually doing a whole heap of work in this space. They're just a bunch of regulators that get together on a regular basis, and they want to standardize how medical devices are treated globally. So they don't necessarily write standards, but they write a lot of guidance materials, and Australia was one of the co-founders of the IMDRF, and in recent days they have other members, affiliate members. So it started in 2011, but it kicked off its software stuff in 2013, and it did a lot of work in this area. And actually most regulators, so they put out these guidance documents, and then most regulators actually have to individually adopt them and write them into the regulation. But if the IMDRF puts it out, generally you can expect that it will be adopted, because it's considered to be, they're considered to be the experts in their field. So the working group for this considers all aspects of it, considers the general regulatory principles, and comes up with a guidance document. So yes, so yeah, the idea is to have a standardized framework that would apply everywhere, just to make international trade a little bit easier, and to bring global regulation on the same page for everyone. So to reduce individual assessment. So yeah, so they have a special standalone medical device software harmonization working group that looks specifically at devices, because that was one of the innovative areas where regulation was lacking quite severely. And they've done some really, really great work, and they've actually consulted everyone on a lot of these documents. And if you guys know anything about consultation, you would know that it's really hard to get people on the same page. So the fact that they've gotten a lot of these documents out is pretty great. So they've worked on the definition of software as a medical device, how you can use regulatory tools such as quality management and apply them to software, and they want to get the regulatory framework structure in place then that each country can then adopt. So this is one of their documents where they look at quality management principles and how they apply to software as a medical device. I'm not going to ask you to know it in detail, just know that it's there. All right, so if you're applying with your device, what will the TGA look at? So they're going to look at, is the product going to be sold as a system or as a standalone software package? What is the intended use and the claims that you make? So IFU, marketing materials, and so on. Is it a measuring and a recording tool, or is it a diagnostic tool? They will look at your disclaimers and warnings, such as, and this software is intended to be used as an observation and measurement tool only, and is not intended, should not be used as a primary diagnostic method for whatever disease. So you actually have to, if that's the indication that you're going for, you have to actually state that in your information for use, and you have to have a nice red warning to say that this is not a diagnostic tool. So they might look at your clinical data and product validation, even if it's a lower class device, and you should still apply Essential Principle 2 and Essential Principle 13 and fill out the checklist, even if it is low risk. So, and again, use this standard. It is recognized as state of the art, and it is directly linked to the essential principles. Okay, and then there's post-market requirements. So this is from the TGA, and they've said that they're, from a pre-market perspective, they're going to look at whether you have adequate evidence and whether that evidence is actually appropriate, which can be a bit hard for software. So they're going to look at performance, they're going to look at your algorithms, they're going to look at your, as I said before, document everything. They're going to look at your design and quality documentations and instructions for use are the big one. And then they're going to look at your classification, and is it appropriate? And does it meet the rules? So the idea is to basically have it fit into the framework that we're familiar with. All right, so I know that there's a lot of software used in manufacturing, right? Software that drives the machines, software that does the analysis. And the question is this a medical device or not? Do we care about that sort of software? And the answer is most of the time we don't. So it's generally not regulated because even though it's used in production and manufacturing, there's no therapeutic purpose. So if you looked at it by itself, it's not a part of a device, even though it's manufacturing one. Are these HIS is Hospital Information System, Laboratory Information Systems, and PAC, I had to look that one up actually. It's Picture Archiving and Communication Systems, so those are not deemed to be a medical device. So you only use them to store information and retrieve it with no device functions or features. So some of the examples are software used in manufacturing, software for maintaining QMS, software systems and tool sets. None of those are medical devices. And then when you get further down that list, then it becomes obvious that it is. But again, they have a lot of room for doubt that they've allowed. So some of the configuration and setup software might be deemed to be a medical device, some of the service tools, some of the measurement displays and graphs. So, yeah. All right. Other considerations. There is a lot of feature creep with software. So it seems like the natural progression of things. So you might have something that slowly, step by step, goes from not being a medical device to being a medical device. So you might have an app that tracks your blood sugar levels. So the first version, all it did was record the level. The second version might record your blood levels and show you an infographic, like a graph, so you can actually follow it on a graph and you can see peaks and troughs. The version after that maybe shows you trends, maybe tells you during this time of day, your blood sugar is likely to be high, during that time of day it's likely to be low, like at night when you're sleeping. And then finally, if it provides an alert, means that it's now officially a medical device. It means it's providing a diagnosis. So if you're at high risk of going into hypoglycemic shock, and it starts to beep and wakes you up so you can, eat something sweet or take your insulin or whatever, then it is a medical device. So it's like a natural progression, and you could do it just with your regular software updates where you enable new features. So yes, so an obvious extension of an existing product may change the classification. This happens a lot. It happens in the US, and it actually happens here. And that red example where I said, put a warning in that says this is used for interpretation only and shouldn't be used as a diagnostic tool. A lot of people use that, de-emphasize the features in order to not have to deal with a classification system. So it's a lot easier to say, even though it has all these components, we're just going to try and market it as a non-medical device because we don't want to go through the conformity assessment process. So it happens a lot. Most of the time you won't get pulled up on it as long as you're actually really clear that it's not a medical device. So it's all about language. So if you say it's an aid in the diagnosis of, or it's a tool to help the clinician decide X, Y, and Z, then it's not a device. But if you say it will, give you a diagnosis, then it is. Yeah, it's a bit iffy. And all they can do is like ask you to, withdraw your device. You can get like sanctions and fines, but I don't actually know of any happening recently. So, all right. So marketing and how the product is promoted and sold is totally different to traditional devices. There's lots of media and public interest in people doing it themselves, as we talked about it. And then this is the biggest issue: is that there's a big proliferation of manufacturers, so-called manufacturers, or programmers, with limited or no medical domain knowledge. So, you can have a 14-year-old teenager who's good at coding produce something that is essentially a medical device, right? Maybe he wants an app that'll track his skin condition or whatever, but this happens a lot, and they can actually put it on in the App Store and have it available to people within like a couple of days, and he might not even be aware of the fact that, hey, it's a medical device. I don't know if I spoke to you guys about, there was this software that analyzed the movement of sperm and helped you select the best sperm to use in an ICSI procedure. And they weren't aware of the fact that it's actually a medical device. So that was, that was a bit of an issue. So then they ended up having to make a statement and withdraw their product. Okay, so the ideal life cycle approach, all of these steps still apply. And then there's the post-market considerations. Now we have a whole lecture on post-market stuff, but I did want to put this in here just from a software perspective. Recognizing reportable incidents is a big issue because most people don't consider that from a software perspective. So by the time you've realized that there's a problem and you've notified the TGA of it, it's already been fixed. Like, you can fix problems pretty much instantaneously with software, and you can fix them like nationwide. So, for example, if you just reboot and then it works properly, most people think you don't need to create a report, and that's incorrect. And then software issues are misidentified as user issues. So people think you don't need to generate a report. And that's, again, incorrect. And these are a really big deal. Most people don't actually link incidents to risk management, so incidents are overlooked. And then, as I said, a lot of so-called manufacturers for software don't actually know that particular procedures even apply to them. So we're not very good at educating that section. And with software recalls, you don't need to recall a device. It's usually fixed by the time it's reported. However, reporting them is still a requirement. But capturing and tracking incidents and complaints is done a lot better with software, because it's really, you can build in a feedback mechanism, and you can have an ability to automatically create and store records. So every time it fails, it probably logs the failure somewhere in the software. So that's an advantage over traditional devices. And ideally, you want the system to be able to force updates or disable certain features and apps if required, which is really, really hard with traditional devices because you have to go into the patient and take them out. All right, so there's a lot of regulatory reform in this area. Like, it's going so quickly that from when I wrote this lecture to giving it today, I had to do 3 new slides because all this stuff's happening. So yeah, each country is doing it differently, but they're all looking at the IMDRF documents. So Europe has just upped their classification for software that provides information for clinical decision making. So they're saying the more likely it is to kill the patient, the higher the classification is going to be, irrespective of anything else. Fair enough. The FDA have decided that they want to do a special pre-market assessment and certification for software. So they have their own program that you have to apply for before you can even think about selling it. And Australia is currently consulting for for putting in like a proper classification scheme for software for clinical decision making and therapy. So this was just done in February, and it's quite an extensive document, and they're saying what we've done up until now is not going to fly anymore. So we're putting in like a proper system. We're going to tell you exactly how to classify software as a medical device products. They're putting a harm algorithm, and they're actually going to exclude software as a medical device product. So this was like a loop that a lot of people use to get software through. So they were saying that it would fall under the personal importation provisions and therefore be exempt from TGA overview. So they're going to close that loop. And they're going to put out some very clear and transparent requirements for demonstrating the safety and performance of software, which I think is going to be great. But until it happens, watch this space. So what I think they're going to do is what the IMDRF, one of the documents, recommended, that if you're looking at the clinical applications of software, they've sort of put in this very complex diagram, which I don't expect you guys to know, but you will see that impact and functionality will determine where your software actually sits. So, and again, if you look at the right-hand side, if it's embedded in a medical device, it's not. So it's still going to be, like closed-loop intervention, is still going to be deemed to not be a medical device from a software perspective. So it'll just go with whatever that device is. Okay, and cybersecurity is another thing that they're looking at completely changing. So they want to tighten this because apparently it's an issue. So there is a risk that if someone, even in today's day and age, if someone knows your pump's or pacemaker serial number and gets close enough to where you are, they can actually hack into the device remotely, right? And there were also known cases of like certain things interfering with you really don't want stuff to interfere with your pacemaker. But initially, early on, when they started putting software into everything, there were such issues. So they're looking at tightening and putting in special requirements for cybersecurity for medical devices. Any questions? No. That's all right. Look, the gist of it is, does it have a therapeutic function? And does it have a diagnostic purpose? And I will not have an essay question in this lecture. So I know it was a little bit heavy and it's a little bit all over the shop just because there's no specific standard that you can hang your hat on. Like normally it's so prescriptive that you either fit it or you don't, but in this case everything's sort of open to interpretation. And I interpret it differently to what someone else might. And I've even seen TJ speakers that are speaking specifically on this topic give sometimes conflicting information on it. So yeah, it is all still a little bit vague, but I reckon by this time next year, there'll be a specific guidance document on it, and it's going to be a very different playing field. So my advice is, if you are developing some sort of a medical app, just keep that in mind and word your instructions for use very carefully. Okay, and if you're coming to the workshop today and you have a little bit of time, please read this news article, because we're going to discuss it, so we're really helpful. It takes 5 minutes. All right. Any other questions?